Okay, this says the figure above shows the graph of f prime, the derivative of function f from -6 to 8. The following which best describes the graph of f on the same interval. Subtle point, notice they left out the endpoints, so we don't have to check that there's anything going on at the endpoints. The endpoints can be locations of maxes and mins, but we don't need to worry about that. So we just analyze the interior. And we're looking at the graph of f prime, so remember what we look for is different. So like f prime is positive here, and f prime is positive here. So I'm going to put like I'm going to note that if f prime is positive, that means that f, which is what we're analyzing, is it increasing. And then f switches to decreasing this entire time. You know, for a moment, the derivative is 0, but then it continues to decrease. So it's increasing in these sections. It's decreasing in this middle section. Okay, this you could summarize this on a number line. But if your derivative changes from positive to negative, your function changes. Maybe I should write that. F is, not f prime. F is increasing, f is decreasing, f is increasing. So what we know here is that since f increases and then f decreases, we have a local max here, right? It's just, the graphs of f is doing that. And then from, at this point over here, it goes from decreasing to increasing, so we have a min. So we've got two relative extrema. We have one max and a min. Before we go on to the second derivative analysis, let's go look at answer choices we can kind of eliminate. So it doesn't have two relative minima. That's gone. So all three of those are gone. And then, so that leaves now it's between A and B, right? So we got to go to the second derivative analysis. Now, when it comes to the second derivative analysis, we look at something different, right? So this is f prime. If f prime is increasing, that means concave up. And if f prime is decreasing, that means concave down. So we can look at this graph now for when it's increasing and decreasing. So I guess right? So it is decreasing all the way until here. So that must mean that f is concave down. And it happens again here. F is concave down. And then here in this middle section, increasing. So f is concave up, and f is concave up. And a switch in concavity like that produces an inflection point. So I have an inflection point, one here, or one at that x value, one at that x value, and then one again here. 3 inflection points. So that means the answer is A. So that's a good review too if you needed some help reviewing those concepts. But the graph of f prime can tell us when f is increasing and decreasing, and hence relative extrema. It can also tell us about concavity, because now we look for when this graph itself, f prime, is increasing and decreasing.